Hello, greetings students. This is audio record for GST 121 Philosophy, Logic and Human Existence, Model 8 Rules of Inference. My name is Dr. Ali Tijan Waziri. These are the highlights of what I want to see in this module. We shall see hypothetical syllogism, disjunction, syllogism, and constructive dilemma, assumption rule, conjecture rule, and simplification rule. Introduction. In logic, inference is the act of drawing conclusions from given information or evidence. In another way, inference is the process of driving a conclusion from existing ones using logical rules. If you see based on what we have seen, what is about this particular inference is drawing conclusion or driving conclusion from existing principles, from using logical rules or principles. And then for a basic notation, we are going to see conditional statement: if P then Q. If P then Q. The key point here on conditional statement is if P then Q. The P is called the antecedent, while the Q is called the consequent. For example, if you see here the statement, if Kano shares border at Katsina, then it is northern Nigeria. The statement Kano shares border at Katsina state is called antecedent, while the statement Kano is northern Nigeria is called the consequent, meaning this is a conditional statement. Now, based on the rules of inference, we shall see what we call the first rule of inference. The first rule is hypothetical syllogism. This is a logical argument that uses conditional statement. Here, it consists of it uses conditional statement, and we use this conditional statement in deducting the conclusion. So we have two forms of this hypothetical syllogism. So here we have example of the hypothetical syllogism. Here we have premise number 1. If it is sunny, then we will go to park. Premise number 2. If we go to park, then we will have picnic. The conclusion here is, therefore it is sunny, then we will have a picnic. So this is the example of pure hypothetical syllogism that comprises of two premises, and all these are in conditional statement. And the basic two forms of this hypothetical syllogism are modus ponens and modus tollens. The first one, modus ponens, is affirming the antecedent, while the modus tollens is denying the consequent. So now first we shall see modus ponens, which is affirming the antecedent. Don't forget here the P here is affirming the antecedent. So mean that phi confirm P is true. P is true. That's what they are trying to affirm, that P is true. So now therefore here we have if P then Q. Symbolically it means P implies Q. As I told you, this kind of hypothetical syllogism is comprises of conditional statement. So we have if P then Q. The premise number 2, P is true, and therefore Q is true. This is affirming the antecedent. Don't forget, the P there is the antecedent, so it's affirming the antecedent, that confirm that if P is true, then Q is true. Example, if it is raining, then the streets are wet. You see, it is raining. Since it is raining, then we are confirming that yes, the streets are wet. You see, here we are affirming the antecedent. We have the modern tolerance. Now this around is denying the consequent. It's a rule of inference. As I told you, it have a conditional statement. And this is the formal structure of the modus tollens. A conditional statement, if P then Q, then we have to negate the consequent. This time around, you see, we have the inverse. It's trying to negate is denying the consequent. So that's why you see premise number 1, conditional statement. Number 2, negation of the consequent. What is the consequent? Q is the consequent. Conclusion, the negation of the antecedent. So we have this example: if the dog detects an intruder P, the dog will bark, which is Q. So therefore, the dog, we have premise. This premise 1 is in conditional statement, but premise 2 is not in conditional statement, based on the formal structure of the modal tolerance. That's why you see premise number 2, the dog did not bark, which is not Q. Therefore, no intruder was detected. You see, not P, based on the formal structure of the modus tollens. If the dog detects an intruder, the dog will bark. The dog did not bark, therefore no intruder was detected. Now we have another form of rule of inference. We call it disjunction syllogism. It's a logical argument consisting of disjunctive premises. Premise, that is, it is an either or statement. So this is how it. Now observe the formal structure of disjunctive syllogism. Premise number 1, we have it as either P or Q. Either P or Q. That's why you have is true. Premise number 2, P is not true. P is not true. That's why we are negating the P. Therefore, Q is true. Q is true. That's why you see premise number 1, disjunctive. Premise number 2, we have the negation. Negation of P is not true. So example of this, we have the meeting is either in the morning P or in the afternoon. Premise number 2, the meeting is not in the morning. Then the conclusion, therefore, the meeting is not in the meeting is in the afternoon. You see, this we call the disjunctive. The meeting is either in the morning or the afternoon. Premise number 2, the meeting is not in the morning. Then the conclusion is the meeting is in the afternoon. We have another rule of inference. We call it constructive dilemma. It's a type of argument where 2 or more conditional statements are presented with another additional statement. That's why you see, along with a disjunction of the antecedents. This time around, this constructive dilemma is it have 2 conditional statements, then it now have combination of another statement, the third one, which is going to be the disjunction of the consequent of the 2 conditional statements. That is, observe the formal structure of it. If P then Q, if R then S. Note that P and R are the antecedents. Then we now combine them with O. That's why you see P and R. Then this inference and conclusion, since it is in dilemma, meaning there are two things together which one have to choose. That's why you see the conclusion is P or is Q or S, meaning it will be one of the consequence of the two statements Q and S. That's why you see the conclusion is Q or S. Now let's see an example of this. Example is, if it is raining, the street will be wet. If it snows, the street will be slippery. Now it is either raining or snowing. The conclusion will be the street will be wet or slippery. The street will be wet or slippery, meaning the conclusion you can't conclude one statement. You have to combine with all. That's why we call it dilemma. Is the last part of the rules. This simplification rule states that if you have a conjunction that is true, then you can infer that either of the statements making up the conjunction is also true. Conjunction, this is simplification rule. We call it conjunction elimination. Simplification rule states that if you have if you have a conjunction that is true, then you can infer that either of the statements making up the conjunction is also true. This is the form. P and Q, you can conclude P. From P and Q, you can also conclude Q. Meaning that that's why you see example is we have the sun is shining, the birds are singing. Premise 1, the sun is shining, and premise 2, the conclusion, the bird is singing. Meaning that this is a statement, the sun is shining and the birds are singing. Premise 1, the sun is shining. Premise number 2, the birds are singing. Conclusions are the sun is shining. So we have this as example. The statement, the sun is shining and the birds are singing. Premise 2, the sun is shining and the birds are singing. Conclusions are, we have, I've forgotten to inform you that this, for this rule it have two conclusions. That is why you see the sun is shining and the birds are singing. So it's the only rule that have two conclusions independently. So that's why we call it conjunction elimination. Here are some practice questions. We have modus ponens where we have 3 questions. Question 1, 2, and 3. And then we have also questions on modern tolerance where we have question 4, 5, and 6. We have modus tolerance also. Then we have disjunctive syllogism, question 9, 10, 11, and 12. And we have the simple dilemma where we have question 13, 14, and then we have assumption rule, question 16, simplification rule, and conjunction rule.